Okay, so in this video clip, we're going to take some C++ code and compare the American European value, but not for Cox, Ross, Rubinstein. We're going to do this for Leisen Reimer. Leisen Reimer tends to be quite fast in converging at low step size, and it does have some advantages. Now, the code originally hails from Fabrice Roua, and we've made just one small change on the original code. We introduced a parameter for dividend yield, and that's just a minor change. So I'm going to copy this code, and I will go into an online compiler, EGB, and we'll start from new online gbd.com. Then we specify the language. It is C++. We remove the segment of code that automatically appears. We paste in our own code, and then we'll take a look at the parameter values, and we'll reduce this to 100, and I'll put in values for the spot price exercise that I'm familiar with. So initially we'll go with dividend yield of 0, volatility of 20%, risk-free rate 5%, time period or maturity 1 year. And when I run that, I should get European, American call and put values, but a European call value of 1045, and I get very close. Look at this for a moment. At 100 steps, we're at 1045. If this was the European for Cox, Ross, Rubinstein, if we can go back to Cox, Ross, Rubinstein, take those same values of 100 for Cox, Ross, Rubinstein. Okay, this is a Cox, Ross, Rubinstein snippet of code that appeared just above Leisen Reimer code. I know it's Cox, Ross, Rubinstein. We have the link. But if I put that t equal to 1 year, and this was 5, so 0, and risk-free rate is equal to 5, and volatility 20, when we run that at 100, we get a value about 1043 for the European call. So it's a little bit out. It's not as accurate, right? Cox, Ross, Rubinstein at low step is not as accurate typically as Leisen Reimer at a low step size. Okay, so that's probably worth noting. The true value with Black-Scholes would be 104509, and we're very, very close with the Leisen Reimer code. With Cox, Ross, Rubinstein, we're 2 cents out. So there's that element of additional accuracy with Leisen Reimer, particularly for European. Okay, so one other thing we could do then is just note that the European call and American call have the same value here because the dividend is equal to 0. Not optimal to exercise the American call early if the dividend is equal to 0. Okay, so that's that is axiomatic, right? Now, we could change this to 5, and you might note then that there will be, it will be optimal to exercise the call early, and the value of the call here is, for the American call, is higher than the value of the European call. Notice that we have a symmetry between the call and the put. When the dividend and the risk-free rate are the same, and the spot price is the same as the exercise, we have a put call symmetry based on MacDonald and Schroeder, and the American values are higher than the European in each instance. So in each case, it's optimal to exercise early, right? Last thing then, we do a quick check just to see, does this work reasonably well for the American option? And we have values from Brody and Temple 1996. And if I have these parameter values, R 3%, sigma 20, dividend equal to 7, underlying asset price 100, exercise 100, then the true value is 9.066 at 15,000 steps for true. Okay, so, okay, let's take that then. And again, for the Leisen Reimer, so we're going at 100 steps. Okay, we'll start with that initially. These values are the same. It was for 3 years using the Brody and the Temple values. The risk-free rate was 3. It was deliberately put less than the dividend so that all call option will exercise early. 20% volatility. If we run this, we should get a value in the region of 9.066 for the American call, and we get a value for the American call of 9.0523. So not too bad. We could raise this to 1,000, but typically once you go over a certain step size, Leisen Reimer's not that much more accurate than Cox-Ross-Rubinstein, right? So we're getting a little bit closer, 9.064 compared to what? Compared to 9.066. So Leisen Reimer is quite a good model, and it's one that probably is worth having in your toolkit. Okay, so we'll stop here.